collection, utility functions, clean architecture code, right? So let's break this down completely and properly again, right? Previously we had this reverse string and input, so this just works fine. We pass string into function reverses it, then it's simple. But Kotlin allows something much more cleaner. What if we could write input.reverse custom, right? Now this reads almost like English, because what it means in English is that it takes input and reverses it. Much more natural, right? And this is exactly what extension functions allow. So we have fun string reverse custom, right? The string dot before the function name is what makes this as an extension function. It says this function extends the string type. It can be called on any one string. Inside an extension function, you can refer to the object the function was called on using this. But we are inside a build string block, which has its own the strong builder object, right? As we can see here, to be specific about which this we mean, right? We use the labeled this syntax, this @reverse custom, and the @reverse custom label refers to the this keyword of the reverse custom extension function, which is the string we called it on. So we have fun main, right? Now instead of reverse string input, we write input.reverse custom. It reads more naturally, which means take input and reverse it rather than reverse the input, right? This is the same result as before, as you can see, if you can do it on your own. So what I mean here is that extension function can be defined for any type, string, int, double, list, your own custom classes. They are incredibly powerful for making your code read cleaner and naturally. And why extension functions are powerful? Because without extension functions, utility code becomes ugly, like really ugly. Because like take for example, like if you do string utils.reverse input or reverse string input in your Kotlin IntelliJ, Kotlin makes it cleaner and more natural, right? And meanwhile, real in Android development is that extension functions are everywhere in Android. Whether we will learn in Jetpack Compose, which will say view.show, view.hide, context.toast, hello. These often are custom extension function developers create themselves, making the code much more readable. And an important thing to understand that extension functions do not actually modify original class internally. You are not changing string source code. Kotlin simply lets function be called as if it belongs to that type. This is what the distinction matters. And some beginners abuse extension functions for everything. That is a bad idea. Extension functions should improve readability, add useful utility behavior, and feel natural for this type, right? Do not randomly attach unrelated logic to the class. This is what you should keep in your mind map. As we know that extension functions are one of the reasons Kotlin feels so expressive and elegant. Because instead of writing awkward utility code everywhere, you can make your own APIs read almost like natural language. Yes, that's it. Now let's talk about function overloading. What if we want to reverse not just string but also integers? Just like turning 45 into 54, right? We could write a complete separate function with a different name, which is reverse int or something. But Kotlin gives us a better option called function overloading. You can have multiple functions with the same name as long as they have a different parameters. So we can see here fun string dot reverse custom string reverse and return build a string. For we will use for loop here. For I in this @reverse custom dot last index down to 0, which means obviously from hello, just like how we saw that hello to 0, right? 5 4 3 2 1 0. The same like here. Append this @reverse custom and iterator, right? Then we have fun int dot reverse custom int return this dot toString reverse custom to int, and then finally our main function, which is val input readline, take input from the user, which has to be integer or a null, right? Then we have the reverse number input dot reverse custom println input plus reverse. Now let me just break this down for you. We now have two functions called reverse custom. Both of them are called reverse custom. One extend string, one extend integer, right? As you are saying, we have string and integer here. Kotlin can tell them apart because the type of object they are called on it is different. Let me just explain it to you once again, that Kotlin can tell them apart because the type of object they are called on is different. I hope you are getting it. And then we have fun int dot reverse custom parenthesis and integer. So this extends integer, it converts the integer to a string using .toString, right? And it calls our existing string, which is reversed custom, on that string reusing the code we already wrote, right? So that converts back to an integer with .to in parenthesis, right? Then we have the input plus reversed. So now let's see. If we enter 45, reversed is 54, so 45 plus 54 is 99, right? For 13, reversed is 31, because 13 plus 31 is 44. There's actually a mathematical name for numbers that when you add them to their reverse given a palindrome, which in simple words, if I have to clear it to you, it is same name different behavior depending on the data type of it, right? And also one more thing about function overloading is that different parameter or receiver type, that is very important concept in programming, right? So the big idea here is that you can see on your screen that the most important takeaway is not the number reveal itself, reversal itself, right? The real lesson is this, that good developers reuse code instead of rewriting it. That's massive, because large applications become impossible to maintain if logic is duplicated everywhere. Meanwhile, professional developers constantly look for ways to abstract logic, reuse functionality, reduce repetition, and keep code clean. And these kind of things helps us a lot. And honestly, if I have to say something, this is where Kotlin starts feeling really powerful, because now you can create reusable code and extend existing data types, right? Like previously we saw on extension functions, extending existing data types, right? And overload functions, writing expressive APIs, chain functionality together naturally, and your code starts reading less like machine instruction and more like an actual language. Just like as I said that you can have multiple functions with the same name as long as they have different parameters, right? Got that? Good. In simple words, multiple functions can have the same name as long as their parameters are different, because Kotlin figures out which function to call based on parameter type, numbers of parameter, and the parameter order. Function overloading is same function name plus different parameters, which is equal to different behavior. It helps code clean, easier to read, more flexible, more reusable. That's why you often see it constantly in professional Kotlin and Android development. Alright, so today we are learning one of the most important concepts in modern Kotlin, which is lambda functions. And honestly, this is the point where a lot of beginners suddenly feel confused, because until now every function we wrote looked like this, which is fun, greet, println, hello, right? This is nice, simple, cleaner, name function. But meanwhile,